Visible?
Yes, sir.
Okay, so we were talking about series and parallel, right? This was the series combination, right? We use Ohm's law. How, Schwab? What about your network? It's not strong. Why you are coming and going? Please on the camera, okay? Schwab, you have to keep on the camera.
Sir, I don't have a camera in
Sorry?
my computer. I don't have a camera in my computer.
Okay, no problem. So try to find another one. So this derivation is okay to everyone?
Yes, sir.
Okay. So Tejasvi, you know how to calculate the R equivalent in the both cases?
Sorry, sir.
Uh, do you know how to calculate the R equivalent in series combination? Can you do it on your own? If not, then you have to practice it, okay? It's already done. In the same way, we calculated the R equivalent for the parallel as well, right? This was some problems. This was one problem. And there was parallel combination. Okay, yeah. This is one of the example of parallel combination, right? Remember? So we went on solving all these. And what next? We calculate the numerical as well. Okay, so I think this was one of the question we solved, that how many current will be distributed if we have one of the more important thing is that in the parallel combination, the current is being distributed in arms. So if I naught is over here, the whole current is I naught, then I1 will be in one arm and I2 will be in this arm. So sum of all the current will be I1 plus I2 will be I naught. This is one of the important feature of parallel combination, right? So when you are going to write the properties or differences in series and parallel, you may have to keep in mind all those minute points. Got the point?
Yes, sir.
Okay, so moving on further.
Sir,
Yeah,
can I have the backup classes for electricity chapter?
sorry, I didn't get.
Can I get the backup classes for electricity chapter from
Uh,
starting?
of course, you asked to admin, okay? You didn't attend all the class?
No, sir. Actually, I was there till a bit, but then I moved. I
Okay,
went
so,
outside. That's why.
okay, then ask to the admin, okay? We may arrange extra classes, okay?
Okay, sir.
Okay, so do you have any issue from where you started?
No, sir. There is some portion where I left, so I need to understand that thing.
Okay, no problem. You will just ask to admin. We may arrange the classes, okay?
Okay, sir.
Okay, now move on. We have the point, next topic, and most probably the last couple of topic of the our chapter. Shoaib, heating effect of electric current. What do you mean by heating effects? How the heat being generated in our electric gadgets? This is the classical example. When we rub our hands, Heat is being generated because of what? Because of friction.
Yes, sir.
What is the definition? What is the definition of resistance? What is definition of resistance? Shoaib, you two are the target audience. Tejasvi, what is the reason of you don't have headphone? You don't have headphone?
Actually, sir, I have the Bluetooth one, but it's not connecting to my laptop.
Okay. So
Sorry, sir.
it's okay, no problem. Sometime my headphone also doesn't work. Okay, it's the machine. So my question was, what is the definition of resistance?
The flow of current. Lect.
Flow of current is not the resistance. The hindrance in the flow of resistance, the measure in the hindrance of flow of currents. Same here. If we rub our hands, there is friction between both palms. What the friction do? Friction opposes the motion. That's why heat being generated, right? That's the simple thing. If you will rub two stones together, you will feel the heat. Same what happens when we flow the current through our apparatus. Suppose this is a current wire, the conducting wire, simple wire. We are connecting with it a source. So current will flow. Current will flow, then there will be motion of electrons, individual electrons. These electrons, due to the structure of wire, feel some resistance, right? Resistance means the opposition in the flow of current. Okay. So due to oppose in the current flow of electrons, what will be the consequence? The heat will be generated, right? Heat will be generated. Got the point? Have you ever checked that overusing the phone makes it hot?
Yes, sir.
Overusing, right? Similarly, you may have seen that whenever you charge your laptop or mobile, the charger also get hot. Okay. Wires are very conducting, 100% efficiencies, say that, or 90%. Then there will be very less heat. There will be very less obstruction to the flow of current. So there will be very less heat. So because of obstructions of the flow of charges, heat is being generated. Sometimes those heats are useless. Maybe those heats are being in transmission line. Those heat loss are the loss of power transmission. Somehow we human being have engineered those heat generations in useful work as well. How the electric iron works. How does electric iron works? This is the example of electric irons we use in our everyday life. We use now.
Yes, sir.
So did you ask the question to yourself how it's working? Being a science student, we have to ask each and everything. As we used to ask to our mama, why you are giving me every day the same curry? We do ask. So this is the repetition. I want it. The same way we have to ask ourselves the questions. Why this works? Now you got the idea how the electric iron works. This works on the principle of heat generation, heating effect of electric current. This is also electric heater as well, right?
Yes, sir.
So these are the different kind of materials. If we will use aluminum, copper, then there will be very less heat generation. Okay, if we will use instead silver wire or gold wire, or there will be very less heat generation. We won't get this glow. Do you use these apparatus in your home?
Yes, sir.
So have you ever tried to open it?
No, sir.
No, you guys are really very obedient people, right? So whenever you will open it, na, if you have electric iron, if you don't know that, you may open the Google, okay, or YouTube, try to search how these materials are being, these operators are being made, okay. So in iron, or even in the electric bulb, have you seen the neon electric bulb? We read already, na, bulb. So what is made of this filament?
Tungsten.
Tungsten. Tunges. Tungsten. Maybe spelling is wrong, right? But make it so. So did you think why it is made of tungsten instead of aluminum? So, Shoaib, you have to respond. Otherwise, it's not the cafe or movie theater. You are just watching. So did you ask a question why it is made of tungsten, not of copper or silver or gold? Never. So from now, you build up a habit and ask why. At least ask to your own self. Okay, why? If you will ask why, at least you will get 10 or 20 question every day. Okay, whenever you are free, you are doing something on the mobiles, phones, or internet, you try to recall all those questions and search instead of randoming going here to there. So tungsten have a specific quantities that it can withstand the high temperature. Okay, because of high temperature, this is filled with the gas, so it is being blown. If we will use aluminum, it will melt at the low temperature, so it won't work. Copper in the same way. So here also we use different kind of materials. Alloy, here we use also the tungstens, same material is being used. Okay, so I will like to draw the figure of that heating elements. Back in home, you might have seen the iron heater used by the what can I say, washerman. Okay, the traditional one. Uh, this type of iron heater, two handles, right? There are one layer up and then one layer down. Remember? So in between these two layers, if we will open it, this is one layer and this is another layer, side view. And there you might have find some shiny plates. Okay, some shiny plates. In between the plates, there might be the coils like this. And then nichrome wire is being, how this happens. This is nichrome wires. I'm not getting why this is happening. I'm not getting why this is happening. I'm sorry. Have you seen such? I tried, but I don't know why that's being removed by itself. I don't know. I'm again trying over here. This is one of the so by the way, you got the idea? And that's plate is being again covered by by some, what can I say, uh, non non-conductor foil of silica, right? So they will be covered in silica cover, and then it is being placed in between over here. Did you get any idea? Govita, I think you might have seen back in the village, right?
Wait, no, sir.
No. What about Tejasvi?
Sir, I have seen,
You have seen.
but I have seen in TVs, not real life.
Okay. So what about the modern gadgets? Modern gadget is much sophisticated. Okay. Modern gadget, if you will open the modern gadget now, you won't feel any physics over there. Because these are very complex. These are some, these holes are for some another different purposes and all. So basically, there is one plate. Okay, over there some wires of heating elements. We may say that heating elements or winded are being rolled over. Then another cover of some heat conducting, but not electricity conducting, silica sheet on the both side. Then again they are being sandwiched between the two covers of iron plate, and then this is being used. Those are the basic concepts. So you now may after all these discussions, you may have some bit idea how it's being works. So now you may write this definition. When electric current is passed through a conductor, it generates heats due to hindrance caused by conductor to the flow of currents. The work done in overcoming in the hindrance of current generate heat in the conductor. This is called the heating effect of electric currents.
Done, sir.
Okay.
Done, sir.
Okay. So now it's point to do some mathematics to understand it better way, right? So how we will understand it? Suppose this is load. This is iron or something, electric iron, not the iron rod. Electric iron. Electric iron, or we say it press as well. Press, electric press. Have you heard this name?
No, sir.
Okay, so we will keep electric iron. Keep in mind what we already thought. So we have to do a work. This is the here the potential difference is V. We have to do a work, means that when we plug this circuit or iron to the main connections, what we do actually, we try to pull the electrons from one place to another place. Okay, so we have to supply some energy for that. So how we will do? We already know that work done is what? Work done is nothing but bringing a charge Q across the potential. Tejasvi, this is clear to you?
Yes, sir.
Okay, so how we are bringing the charge? Charge per, per unit time. V into Q over T. Work done per unit time. This is what work done per unit time. How we will define the power? How we define the power? Power is work done per unit time. Work done per unit time. Per unit time. So we have to bring the charges from one point to another point per unit time. That will be the power, electric power. So work done, we already know from our previous classes, is that to bring a charge from one potential to another potential, we have to multiply it with V into Q, right? This is the work done. So work done per unit time is nothing but power. So we will say that this is power, P. So this is already V we know, charges we know, time, charges, charge of electrons that flows in the circuit, but we are not aware about the time. It will come in seconds. It is being loaded. Okay. So how we define the current? Q over T is what? Q is equal to IT, right? We all know this relation. Do we know this relation?
No,
Do we know
sir,
this relation?
No, sir,
Q
we
is,
didn't.
okay, what is the definition of current? Q is equal to charge per unit time. What is the definition of current? Charge flowing in conductor per unit time is current. Current is charges flowing through a conductor per unit time. Per unit time. This is the definition of current, right?
Yes, sir.
So this is what Q over T is nothing but this Q over T. We define the work done. Work done per unit time is power. So we are getting power is VQ over T. Clear? Now Q over T is nothing but the current. So this power will be equal to V into I. Clear? This P is equal to VI. Clear till this point?
Yes.
Yes, sir.
Okay. Now using Ohm's law, we will be using Ohm's law. This is one form of the power. See, can I remove this point, these points? Can I remove this much?
Yes, sir.
Okay. So I'm making a space. Make sure that you have written it down. Schwab, there is no response from your side. Okay, so what now I will do? These two quantities. If V and I is known, then we will simply calculate the power. Got the point? If V and current is known, we have to use the power P is equal to VI, right? If some in another form as well, we know that P may be written as V is equal to IR into I. So what is this Ohm's law? V is equal to IR. Let me see. This is Ohm's law. V is equal to I time R, right? This is Ohm's law. We already studied Ohm's law. Tejasvi, any
Yes, sir.
confusion? Any
No, sir.
confusion?
No, sir.
So now what we will be writing it? We will be writing it like power is nothing but I square R. I and I will be multiplied, so it will be I square time R. So this is another definition of power, right? Clear? Now we may change I in another relation. So I will be what? The second relation, third relation. Let me see. Do we have some space around? Okay. So if we have I and R, so in the question, current and resistance is given, we will use this equation number 2, right? If we have another form like that, this where is the Ohm's law? Ohm's law is V is equal to IR. This is Ohm's law. We always keeping in mind. So now if I substitute I is equal to V over R. If we will substitute over here, what we will be getting? I'm removing this equation. So now just keep P as it, V as it, and substitute I is equal to V over R. So what will be the solve these equations. Shab, Babita and Tejasvi, solve this equation and tell me what is the final result. Did you solve this? What is the final relation? Tejasvi, what is the final relation?
Just a minute.
Sorry?
So I'm
Kavita.
solving. Just a minute.
Okay. See, this is V into V divided
So
by R. Yeah, say.
V square, V the whole square by R.
Yeah, V square over R. Here the relation is V into I. Here is relation in V into R. Here is relation between I into R. So in all these cases, you may use these equation depending upon the information we are given, right? Done?
Answer.
Okay, so now this is where is this? This is question number 11.10. What is the current in each? What is the current and resistance in each cases? We are giving voltage. An electric iron consume energy at rate of 480 watt when heating is at maximum and 360 watt when heating is at minimum. So how we fix the heat, maximum minimum heating? This is the knob, right? This will be written here woolen, somewhere cotton, somewhere low, somewhere high, right? This is the knob, na? The same knob over here. So when you are turning the knob, you are consuming the energy according to the need, right? When it is high, 840 watt. When it is low, 360 watt. The voltage is given at 220 volt, that is standard supply. So now question is being asked, what are the current and resistance in each cases? We have all three relations. If P is equal to V time I think this is only the enough for this case, because voltage we have to calculate the current, and another will be the voltage into resistance. Then V is equal to P is equal to V and resistance. Then I is equal to what? I is equal to this maybe V square over R. Another will be I is equal to V over R. So V square over R. So I think these two relation will be enough to solve these numericals. Okay. Can you proceed?
Yes.
Okay. First solve the first part. Okay. First solve the first part and then discuss, then move to the next part.
Sir,
Yeah,
3.81.
3.81, right. So how we'll get the 3.81? We have to find the current. Tejasvi, what about you? And Shoaib, what about you? See, this is the energy. Hmm, it's not visible. See, how we will do. See, this is the energy. Energy is what? Energy will be power. Energy power is work done per unit time, and energy is the same quantity. So we will substitute 840. We won't put the watt. Okay. And then what is potential? This is 220 times current, right? So in first question, we have to solve the current. So current will be just 840 divided by 220, right? And this will be 10 to 10 cancel. And how much this will be? 84, 84 by 2. Just do it. Whatever you get, that will be the results, right? When it is heating is maximum. When heating is maximum. Heating is maximum, right? So did you get Schwab? Schwab is completely gone. He just log in and then I don't know. The next day he will come and say that, sir, I didn't understand. Okay, you got 4. Just divide. Schwab divided. It is less than 4. 23 is 66. 24 is 88. So it is less than, you are around 4, but you have to be a bit precise. Okay. You got the part 1. What about the part 2?
1.3.
Okay. Part 2, we have to find the resistance. So we may use this relation or we may use Ohm's law. V is equal to IR. The V is already given. Current we already calculated. Then R we can solve. Then R will be nothing but V over I. V is already 220 initial. And I is what? This 3.82 or 3.82. So you will solve it. How much you will get? You may use this relation to calculate the resistance also, but here you will see that it is V square means 220 into 220, then divided by the R. Sorry, then divided by P to get the R. So either way is true. And similarly, try the next one when when heating is minimum.
Done, sir.
Both part.
Yes, sir.
Okay, then if both part is done, then we are leaving with one more concept. And I think that's not possible to cover in this 4 minutes. Tejasvi, what about you?
Sir,
What
I have
about
sent the
you?
answer in chat box.
You send it in the chat box. Okay. Is you're 57.4, right? And 134. I don't know what you are saying. So did you understand the concept to solve this problem?
Sir,
Yeah.
so we can directly divide, right, by like 360 divided by 220, right? By cancelling the zeros.
Here in
Like,
the another part, na? In this part, right?
yes, sir.
Of course. You have to be a smart. You have to be a smarter, okay?
So I have done like that only, so it's very simple to do.
That's then you might have seen very easy relations and all. So what the Govita is saying, instead of her point is, then this R is V time A. We are giving 220 and I is 884 divided by 220, right? So it will be again 220 divided by 884, right? This is nothing but this equation. This equation. V square over R. V into V, 220 into 220 divided by R. R is 884. That's power, sorry, divided by power. We have to find R na. So R will go that side, then it will be V square over P. Right? So see, this is the same. V into V, 220 into 220, power is 840. So divided by 840. That's it. We did like this is being solved using Ohm's law. This is just Ohm's law. Right? And this is the formula we have obtained over here. So both way is okay, right? Got the meaning of all these mathematical definitions?
Yes.
Any confusion?
No, sir.
Sir,
Confusion will be only when you will go back and read yourself. Okay. So we are done with today's class.